All right, so we'll give this a go. You write them down one at a time. So title it. It is 8.5, adding and subtracting rational expressions. I'm calling this adding ratios, aka otherwise known as fractions. Just to have you warm up and remind you why we're about to do what we're about to do with rational expressions. So yes, I asked Raph downstairs, what is the key to adding fractions? We need a
equal
common denominator. So do these have a common denominator?
No. So you multiply.
And do they have anything in common?
The fives.
Well, do the denominators have anything in common? No.
They're both multiples of 35.
So their least common denominator would occur if I multiplied this guy by 5, and whatever you do to the bottom, you have to do to the top. Why? Because what's 5 over 5? 1. So fundamentally, I haven't changed this ratio. I've multiplied it by 5 over 5. And now I've got to do this guy by
7.
7 over 7. Right. So that's kind of the always works method. I just multiply this denominator by that denominator, and I multiply this denominator by that denominator. In this case, that makes sense because they don't have anything else in common. We tend to try to look for the least common denominator. I'll get to that down here. So yeah, now what do I have? 5 times 5 is 25 over 35 plus 21 over 35. Now I just add 25 plus 21 over 35, and that gets me 46 over 35. What's that? Yeah. And if you've done it correctly, you shouldn't have to reduce this. There should be no reducing at the end if you've done it correctly. You haven't done, there's nothing redundant happening here. In this case, what do I have going on? I just want to kind of make a point about something here. So this is 5 over 7. What do we know about 35?
It's 7's a multiple.
It is. I can factor 35, can I? Right? The factors of 35 are 7 and 5. So I don't need to do anything to this guy, but I do need to multiply this guy by 5. I mean, if I went back to my method up here, if I want to multiply this guy by 35 and this guy by 7.
Wait, why can't you just multiply 1 by 5? By the first one by 5. And keep the other one as 35.
That's what I am doing.
Yeah, but why did you factor it out then?
You'll see. You'll see. You have to recognize that 7 is a factor of 35. That's all I'm saying. I'm being very intentional about what I'm doing. Have I changed this? Have I done anything to this? What did I do? I just wrote 35 as 2, what are they called? What are these things called? Factors. Just to show you that that's the case. My point is, I could have multiplied this by 35, and this by 35, and this by 7, and that by 7, and yes, I would have gotten a common denominator, but it would not be the least common denominator. Okay, so again, I have 25 over 35 plus 3 over 35, and that just gives me 28 over 35. Simplest form. Oh, that's not right. 28 over 35 can be reduced, can it? Oh, that's because there was a 5 up here. And 5 down there. Right? 7 goes into both of these. Divide by 7. 4/5. I don't really know why that happened, because normally you should get... I'll just leave it at that. Okay.
Are you videoing this?
I'm trying. I've never done it before. Except the screen just blacked out on me. Does that mean it's not?
What, did you press play?
Is there numbers ticking out to see how long it is?
Except the screen went blank. Is that just my screensaver? Does that mean it wasn't?
I have no idea.
We'll try it. Okay, so here, Patrick, I'm going to answer your question. How do I want to write 14?
72.
7 times 2. And how do I want to write 35?
7 times.
7 times 5. Because now I can see, what does this denominator have that this one doesn't? What factor does this denominator have that this one does not have?
2.
A 2. So if I multiply that guy by a 2, that means I have to also multiply the numerator by 2. Then what about this one now? What one does this not have that this one does have? So I can multiply by a 5 and a 5. So writing it as factors, I feel like allows you to see what the least common denominator is. So now I have 25 over, what's 14 times 5? 70. And here I have 6 over 70. So I get 31 over 70.
Yeah.
Okay. So that is remembering how to add fractions, finding the least common denominator. And Charlotte, will you take one of these and give one to Patrick and one to Cole, please? I'm going to erase. Any reason not to erase? I don't know what the deal is with that. All right, so I need one. Here we go. So these are just problems from the book. They're on page 586. So 3x squared over x minus 8 plus 6x over x minus 8. They have a
Common denominator.
common denominator. So that's just 3x squared plus 6x over x minus 8. I am going to caution you to factor the numerator just in case something can factor out. So what common factor do these guys have?
2. 3.
3, and they both have an
X.
x. So if I factor that out, I'd get x plus 2 on the top, right? Just in case, you gotta look for things, because what I factored out might actually cancel with what's in the denominator. It would also help you find zeros to the function, which I've ignored for the time being.
So is that it? Like we leave it like that?
So I would leave it like this, yep. You could tell me where the vertical asymptote would be at x equals
-8. 8.
positive 8, yeah. All right. X minus 4 over 5x minus 12 over 5 times x minus 4. So this is where I would go back to that old plan. What does this one have that this one doesn't? What factor? I have a,
-4.
the denominator. I have a 5 and then x. And here I have a 5 and then x minus 4. You can't just say the minus 4. This is an x minus 4, this is an x. So what does this guy need? It needs an x. And whatever I do to the bottom, I have to do to the top. So now there's a 5 and an x minus 4, yeah? And here I have a 5 and an x, so I need an x minus 4. And whatever I do to the bottom, I have to do to the top.
Did you just do x minus 4 to the side?
I am going to actually FOIL this, and you'll see why, so that I can combine like terms. What happens when you FOIL that? You're going to get x squared minus 8x, because you're going to get a minus 4x minus 4x
16.
plus 16. And now that I have a common denominator, I can subtract my 12x, correct? And in the bottom, we should write things in conventional order. Who should come first? The 5, then the x, and then the x minus 4. And then I should simplify the numerator. X squared minus 20x plus 16. And again, we want to leave the denominator in factored form, because if we were looking for vertical asymptotes, we'd want that. Can this be factored? Factors of 16 to add the 20. We got 4 and 4. We got 16 and 1. That's it, isn't it? 2 times 8. None of those will give us 20, right?
No.
So this can't be factored. We're done with that guy. All right, 22. Anybody have a suspicion about what they want to do here? Yo, go.
Well, that one's got a square and the other one doesn't, so we got squares, essentially.
What have we been doing to try to identify the least common denominator?
Factor.
Factoring. So what if we factored this? What is x squared minus 4 factor to?
X squared, x,
The middle term cancels.
2 and 2.
Plus 2 minus 2. Which makes us happy, because now, do we need to do anything to this guy?
Oh, so we
You have
just
to.
add a plus 2.
A plus 2?
It's x plus 2.
Yeah, this guy needs an x plus 2, and whatever I do to the bottom, I have to do to the top. But now they have least common denominators, which if I took x squared minus 4 and multiplied by x minus 2 and took x minus 2 and multiplied by x squared minus 4, that would have been like the doing 5 over 7 plus 3 over 35. That would have been like multiplying this by 35 and multiplying that by 7. There's no need, because there's already a 7 in here, right? Over here, there's no need because there's already an x minus 2 in here. But you have to factor to see that, which was the question you asked me at the beginning. Viv, why are you writing it as 7 times 5? Because I want you to see that 7 is already in there. All right, now we got to do some simplifying. X plus 4 minus, and I'm going to distribute 15x. Now this is one of the tricky ones. I have to minus 15x, and I have to minus 30. Does everybody see that? This would be 15x plus 30, but I have to subtract the whole thing, so everybody gets subtracted. And I'm going to leave the denominator factored, identify my vertical asymptotes. Now I'm going to combine like terms. Looks like I got a negative 14x minus 26. I think if you factored out a negative 2, I don't think that would help you. There's no common factors in the numerator or the denominator. This isn't necessary if you got to here, but again, we got to just make sure there aren't any common So what's the name of the game?
Factor.
Factor to find the
Least common.
common denominator. Yep. Back in the day, do you remember finding LCDs?
Oh my god. Our
Yes.
teacher drilled it into her head.
Good.
She
Drill. We should have more
she
drill
came
and
up with
kill.
a song with it.
A song. I'm not much on the songs, but if she taught you how to do that till your eyes were bleeding,
Pretty much.
bless her soul. X plus 3. I fear that you can't really see these on the video. I don't know if I have any new markers. Maybe the green will be better. Cole, what do you want me to do? Factor!
Worst case is I can just send, like take a picture of my notes and send it, but then they still listen to the video and see how it's.
Oh, they could listen to it. Good idea. Alright, so yeah, I'm going to factor. X plus 3. Well, I was just thinking, like, if next period I want to teach you guys how to solve, those guys could watch the video and do this, hopefully on their own. Factors of 8 that add to 2. Or combine to be 2.
4.
4 and
2.
2. And my 4 is going to have to be negative, and my 2 is going to have to be positive. I like to put all these things in parentheses because it reminds you that I'm subtracting this entire thing. And again, if I have a positive over here and a negative in the middle, what's the only way that's going to happen? A negative, negative. Because a negative times a negative is a positive. So factors of 32 that add to 12.
6.
4 and 8, yep.
4 and 8, yeah.
For the sharp of mind. Now, what does this guy have that this guy doesn't? And what does this guy have that this guy doesn't? This guy needs an
X minus 8.
right, and whatever I do to the bottom, parentheses that, I gotta do to the top. And now what does this guy have that this guy doesn't? This guy still needs an X plus 2. This is where where your foiling will come in handy. If you can quickly foil, this is gonna make your life a lot easier. But do you see how factoring allows us? I mean, do you want to multiply? Who wants to multiply this trinomial by that trinomial? Raise your hand. Okay, well, you can see me after school and we can do.
We could do
Lots
the
of
whole thingy with the boxes.
Yeah. All right, so we got to FOIL this numerator so we can combine like terms. X squared plus 3x minus 8x gives me a minus 5x, and then negative 24. Now here's what I'm going to do. I got to subtract everything I get over here, so I'm going to put a parentheses in. X times x is x squared. Outer is 2x. Inner is negative 5x. Together they make a negative 3x. And then last is a negative 10. And that's all over my 3 factors. There is my common denominator. X minus 8, x minus 4, x plus 2.
But it's not. It's just big.
It's a lot, yeah. And I tell people all the time, look, you know what? Calculus isn't that hard. It's keeping track of all this kind of stuff that's hard. The calculus, you kind of have these algorithms you just sort of plug things into, but then you get these big polynomials and you have to keep track of all your negatives and all that good stuff. So,
It's like a Rubik's Cube.
I'm going to do this once intentionally, and then we can be quick about it. But I have my x squared minus my 5x minus my 24, but we have to recognize I'm going to subtract an x squared. And when you subtract, that becomes a plus, right? And when I subtract, that becomes a plus. And again, that's all over this. Your x squareds actually cancel. I have a negative 5x and a positive 3x. That's a negative 2x. So I took care of those. and a negative 24 and a positive 10 is a minus 14. And again, that's all x minus 8, x minus 4, x plus 2.
Why do the x's cancel?
X squared
X squares.
minus x squared. 1x squared.
No, it's plus x squared. I just kidding. No, sorry.
Psych.
1x squared minus 1x squared. They're gone. And I can see that I could factor this numerator, but again, it doesn't help me. I think if you do everything right, you shouldn't have any, I think it should be simplified. I can't explain why that one we did before wasn't simplified. Oh, now, this is what I expect you to do at a minimum. This is what I would say is the standard. If you can do these, you are meeting the standard. You should be able to add or subtract rational expressions by finding the least common denominator. Now, the next ones are, you know, it's a skill that if you have, will just make you stronger. That's all I can say. I mean, I recognize that depending on your foundation, you may or may not be able to access this stuff, but I like to throw it out there.
Oh my god.
What?
Nothing. I just looked at 34 and 32.
Yeah, exactly. I'm going to try to make them, I'm going to try to make it not so intimidating. These are the kind of problems I actually like, but I guess that's what makes me a little bit of a nerd. I'm embracing my nerdiness. I might need to get rid of this down here too. Alright. Here we go. Yeah, this is what I like to say. What is yucky about this?
Nothing.
Oh.
The fractions and the fractions.
The fraction, a fraction within a fraction. You guys have fraction phobia to begin with. What is actually going on in a fraction? What does that mean to do?
Division.
Divide. How do we undo dividing?
Multiplication.
We multiply. So here's how I take the first step in undoing a fraction within a fraction. What is going to undo dividing by x?
Multiplying by.
I'm going to do it in red, sorry. I'm going to multiply the numerator by x. And what's going to undo the 5? Dividing by 5.
What's the multiply by?
Dividing, the opposite of dividing by 5 is multiplying by 5. Now, yes, it's true that I am multiplying the numerator by something different than the denominator. Oh, but I'm not allowed to do that. So if I multiply this by 5, I also have to multiply that by 5. And I multiply this by x, I have to also multiply that by x. Does that make sense?
Mm-hmm.
So this x was to get rid of that. This 5 was to get rid of that. But I have to keep all things equal. So what is 5x times 15? What's 5 times 15? 75?
Yeah.
X. Right?
Is that for the numerator of the denominator?
I'm just doing the numerator right now. I'm just distributing my 5x to 15. Right? I have a 5x, I have to distribute it to 15, and I have a 5x, I have to distribute. So the x undoes the x, so I'm left with 5 times 2, which is...
Negative 10.
Yeah. Wow, does that numerator look a lot nicer now?
Yeah.
Yeah. Yeah.
Why was it that?
Can you wait till we just finish this problem?
Yeah.
Well, we're almost done. Okay, well let me just finish this. So 5, this 5 undoes that 5, and I'm left with x times x, which is
X squared.
x squared. And then 5 times 4 is 20x. Now, I should factor just in case to make sure nothing cancels. So what do 75 and 10 have in common? 5. So this becomes, 15x minus 2. Is that right?
Yeah.
And this has an x in common, and this would be x plus 20. So there's no other common factors. So that guy's simplified. I think I'll leave it at that because that'll give you guys enough to practice. I won't do that last one. Actually, isn't that bad, but if you want to get to that one, I can do that with you independently. But let me see.